In this video, I will show you how to analyze the data that you have exported from the iOLab software. It exports it as a CSV file, so you should first navigate to the location where it stores the CSV files that it exports and then double-click the exported file. When you do that, it will open up as a CSV file, so the first thing you should do is you should save it as an Excel spreadsheet. So select the appropriate format and then store it in a particular location so that you can access it. So I have called this force raw data and I've saved it as an Excel file. The next thing you want to do is you want to get rid of the extra data, right? So you'll find that there are multiple columns. The first column is the data index, and then you have something called the frame and then the sample, and then literally the one after that is time, and then you have the raw data and then the calibrated data. So depending on your calibration, you might find that the tension that you read from the force sensor, or rather the force sensor reading, is a negative number. So the first thing you want to do is to get rid of the negative sign. So to do that, create a new column, and we want the tension in newtons. So we're going to just take the absolute value of the column to the left of it. So you can see here that I've just taken the absolute value of that. So click that, and then at this very end over here, just double click that little corner. So when you do that, it will do the absolute value for all the columns, and you'll see it in a moment. There's a whole bunch of data. There's about 63 or 64,000 data points in my export. It may or may not be the same number depending on how long you recorded the data for. So as you can see here, it has removed all the minus signs and just converted it to an absolute value. So the next thing I want you to do is to select all of this data, copy it, and simply paste over here, but don't you have to do something called a paste special. So you have to right click and then select paste special and just paste the values. And the reason why I want you to do that is because I'm going to get rid of this column, and it's a little bit of a nuance, but just bear with me here. So what I'm going to do is I'm going to get rid of a number of columns. So I'm going to get rid of all these columns, so the raw data, the calibrated, and the calculated absolute value data. So I'm going to get rid of them. So bear with me while it deletes itself. So there's a lot of data, as you can see, so I'm going to get rid of all of that data. So it takes a little while to do it because there are about 65,000 data points. After that, I'm going to get rid of these two columns, the frame and the sample. So let's get rid of them as well. So now you can see that we're just dealing with the index, the time, and then the force reading, the absolute value of the tension. Okay, so what I want you to do is to create a new column here. We're going to call this mod 1000. So what we're going to do is there's a lot of data here. We only want every 1000th row, right? So you can see there's hardly any variation. So the variation here is nothing. So you just want to pick out every 1000th row. That's because the time step here is at the 4th or 5th decimal place, right? So if you were to plot this, you would get a whole bunch of data points, and it wouldn't be very useful, right? So what you want to do is to just pick every 1000th data point. It's a bit like smoothing the data. So what I'm going to do is I'm going to go put an equal to sign and then type mod brackets and then pick the first index, comma 1000. So what it's doing is it's taking this and then dividing it by 1000 and then telling you what the, whether it's is divisible by 1000 or not, right? And if so, it tells you what is the remainder, right? So it gives you all these numbers. So what you want to do then is you want to sort through these and pick out the zeros, right? So the first one is a 0. Let's scroll down to this 1000th one, right? So I think 1002 probably is going to be a 0. Yeah, so 1002 is a 0. So similarly, you'll find 2002 will be a 0. So let's scroll down to 2000. Here it is. So here we go. So 2002 is a 0, right? So in that way, you'll find every thousand, you're just picking out every thousandth one, right? So the next thing I want you to do is to select this entire column, and then you'll find the sort or filter icon in Excel. So I want you to click on that and then say filter, because you want to filter this data. As soon as you click that, you'll notice a little drop down arrow appears here. So click that drop down arrow, wait for it, and then you'll see that all of these are selected. So I want you to deselect all and then select only the zeros. So it just selects the rows corresponding to the zeros. Okay. So what we're going to do now is we're just going to plot our time versus force, right? And we're going to see what it looks like. So even there's a lot of data, but it'll be nice to see what this data looks like. So let me just go and plot this. So go into Insert, Chart, and then plot a scatter plot. Right? So you can see it looks like this. So here is the first regime where you held it, where the pebble was submerged inside the can of water, and the water level was dropping, but the pebble was still fully submerged. And then at this point, the pebble starts to emerge from the top surface of the water, and then the water continues to drain more and more as the pebble gets revealed. And then finally over here, the pebble has completely been exposed. The water level has dropped below the lowermost point of the pebble, and thereafter the tension in the string is simply the weight of the pebble. Right? So here the tension is alleviated a little bit by the buoyant force, whereas out here in regime number 3, the tension is the full weight of the pebble. In between, the pebble is partially submerged, so the buoyant force is diminishing from this level to 0. Right? So you have this little curve here. So what I want you to do is to right click on this and then say move chart, and I want you to move it to a new sheet so that it appears nice and large. So you can see here the data that's been blown up. So you can see there's multiple duplicates of data. That's because we're sampling every 1,000 time steps, but still there's numerous duplicates here. That's because the increment in the force is not so high. So it samples very quickly, but the force hasn't increased appreciably within that time step. So there's a lot of duplicate of the data. What we're interested in is this curvy portion of the data. We've already analyzed the flat regions in regime 1 and regime 3 to get the average values. We're just interested in the in-between region now. Okay, so we've now removed every 1,000th data point, or we're only considering every 1,000th data point. So what we'd like to do now is to analyze this portion, right? So we want to excise this stuff, and we want to excise this stuff. So to do that, you have to go back to your data. Okay, so go to the very top of your data. Okay, and you'll see that the initial part of the data flatlines at some value, right? For my case, for the pebble, it flatlines at 0.594467 newtons, right? So what I'm going to do is I'm going to scroll through my data and find out when that, so in between you'll find some variation, but it's not appreciable. It sort of comes back. This is just inherent to the to the fact that the force sensor, there's some jiggle in the force sensor because it's a spring, and so every now and then the value slightly varies, but then you can see it comes back down to the original value, right? So you have to find the location where that starts to diminish, because the buoyant force starts to diminish, so the tension starts to increase, right? So let's scroll down, and I believe for me it occurs around the 39-second mark, right? So you can see here the value increases from about 0.594467 to 0.608802, and thereafter it continues to increase, right? So I'm interested in this data, right? So this is where that uh, increase in the tension occurs, right? So, but we want to see until the top part. So we're going to select all this data until it flatlines again. So keep selecting this data until you find the part where it starts to flatline. So for me, I think that occurs somewhere around the 64th second mark. So around here, this value of 0.7951 is the average value that we read of regime number 3 when we looked at the analysis part of the force sensor reading, right, for that regime. So I have selected only that part of the data. So once you've selected that region, right, just copy that region, and then I'd like you to open a new sheet and then paste it here. Okay, so you can see that you have far fewer readings now. For me, there's only 123 data points. It's far easier to deal with 123 data points than thousands of them, right? So now we can plot this data. So select all that data and then go to Insert and then select an XY scatter plot. And this is the curvy portion of the data, right? The portion of the regime where the tension increases because the buoyant force is diminishing as the water recedes, or rather drains out, and so more and more of the pebble is exposed. So once again, right click and move the chart to a new sheet, just so that you can visualize it better. Then I'd like you to right click on the data and then add a trend line. And I want you to add a polynomial of degree 2, and I would like you to display the equation on chart. So click this and then click polynomial in degree 2. Once you've done that, you should get the polynomial appearing there along with the equation. And you can see the trend line is a very mild looking line that passes through the data. So I want you to do a couple of things. First, I want you to select the equation, right click on that, and then edit the font, and so you can make it nice and big. Okay, and second, I want you to right click on the trend line, then format the trend line so it's visible. So go to the color of the trend line. I'm going to make it black so it's easily visible, and I'm going to change this to a 5-point and change the line type to a solid line. So there's the trend line that goes right through the data. So you can see here, this is the equation for the trend line, and you can see that it is a quadratic equation, and notably the prefactor for the highest order term is a negative value, right? So this is an inverted parabola. This is exactly what was derived for how the tension should behave between those two regimes when the water level starts to drain, drop, and more of the pebble gets exposed, right? So this is the expression that you are hunting for. So you should make note of this equation and you will use it in your analysis.